Nice. Okay, solid system of linear, just a couple more of these. So maybe some weird stuff happening. Y is greater than 1/3 x minus 2. So here's my minus 2. A slope of 1/3. So up 1 over 3, up 1 over 3. And that should be dashed. Something like this. And I'm shading above because the big side of the arrow is next to the Y. So I'm shading up. So it's all of this. And then for my second one, I have a y-intercept of +2. And still a slope of 1/3, so up 1 over 3. This is greater than or equal to, so that's going to be a solid line. And then this is also greater than, so I'm also going to be shading up, which is up here. So I guess the overlap is just this very top portion, like including this solid line, because that solid line is where the red is dashed also, and then like up. It's going to keep going up here. That's where the overlap is. Okay, last one of these, number 9, I have y is less than or equal to x. So be careful with this one. It has a slope of 1 and a y-intercept of 0 because I didn't put an extra number on there. So y-intercept is 0, slope is 1, so it's going to look like this. And it's going to be a solid line, so it's going to go diagonal right through my graph. Notice like y equals x is the part where literally the y coordinate is equal to the x coordinate. So that's like 3, 3, 4, 4, 5, 5. That's what it should look like. Less than or equal to, so I'm shading below here. This one is y is greater than or equal to x plus 2. So here's the plus 2 x. So these are parallel. And this is greater than or equal to also, oops, not that one. Keep going. There we go. Oops, a little. Greater than or equal to means shade above. So once again, they are going opposite directions. There's no overlap. So this is no overlap, no solution. No overlap, no solution. Yep, I think we're okay with those. Okay, write a system of linear inequalities represented by the graph. So this is going to have 2 inequalities. We're going to have one for the dashed line and one for the solid line. So for the dashed line, first off, I'm just going to like pretend that it's a solid line. So it should be like y equals mx plus b. So the slope, if I counted that, that's just up 1 block over 1 block. So it's going to be 1x or just x. And the y-intercept is 0. So that's just x. This is a dashed line and the shading is happening below it, below that line. So this is just y less than x. If I look at my other equation, it's just flat. That's just going to be a y equals a number, and that's down 2. So this is y and -2. It's a solid line, so it's either going to be less than or equal to or greater than or equal to. And the shading is happening above it, so it's going to be greater than or equal to, or this one. Greater than or equal to means that the big side is open to the letter. Y is greater than or equal to. So that would be our system. It's just these 2 equations right there. On the second one, this one looks like it's going to be easier, this straight up and down one. That's going to be x. It's going to be solid, so it's either less than or equal to or greater than or equal to, but the shading is happening to the left of it. So that's going to be x is less than or equal to the number where it is, so that is at 3. So x less than or equal to 3 is that one. My dashed line will be a little bit trickier. So it has a slope. Let's find, here's a good slope. So that's up 2 over 3. So it has a slope of 2/3 and a y-intercept of 1. Oh, I have to be really careful. The y-axis is way over here. So my y-intercept is actually way, like here's my y-axis, and my y-intercept is at -1. So B is at -1. It's dashed and the shading is happening above it over here. So that's going to be y is greater than 2/3 x minus 1. So that's my system. I have those 2 inequalities, x less than or equal to 3 and y is greater than 2/3 x minus 1. Okay, last thing, which we got SpongeBob down here. It says you have at most, okay, so at most 8 hours to spend at the mall and at the beach. So you have 2 places to be. You want to spend at least 2 hours at the mall and more than 4 hours at the beach. So 4 hours is not good enough. 4 hours and 1 minute would be fine. Write and graph a system that represents the situation. How much time can you spend at each location? So I'm going to call X the mall and Y the beach because they came in that order. So if it says you want to spend at least 2 hours at the mall is X. So at least 2 means greater than or equal to 2. And then you want to spend more than 4 hours at the beach. So the beach is Y. More than is like a strict more than 4. But altogether, we only have 8 hours total. So the number of hours we spend at the mall, which is X, plus the number of hours we spend at the beach, which is Y, that altogether has to be less than or equal to 8, because that's all the time we have. So we have a system with 3 things in here. Let's go ahead and graph this X greater than or equal to 2. So here is 2, X equals 2. Greater than or equal to means shade this side. I'm just going to do this really lightly. Y greater than 4, that's going to be a dashed line because it's greater than, sitting here. And we'll shade above that. Starting to take shape. And the last one on here, maybe I'll make this green. X plus Y is less than or equal to 8. So I'm going to rearrange this, subtract the X over. So I have positive Y is less than or equal to negative X plus 8. So plus 8 here. Negative X means I have a slope of negative 1. And that's a solid line. There we go. And less than or equal to means I should shade below that. So I'm shading down here. So the only spot where they overlap is this little triangle right here. Here's the triangle where they overlap, but not along the bottom red line. So there's not a ton of room in there. There's going to be like some fractions. For instance, this point would work. This is the point 3, 5. So that's saying 3 hours at the mall and 5 hours at the beach. This point would work. That should be right on that line. I'm just bad at graphing. That's the point 2, 6. That's okay. This point does not work. That's the point 2, 4. Because you said that you wanted to spend more than 4 hours at the beach. So 4 isn't quite good enough. But the point right above that, which is 2, 4.1, that is okay. Check. This one is not okay. This one checks off. This one checks off. And you have more points in there. You can do halves in there. Like this would be a half right in here. This would be 2.5, 5.5, and that would check out. You're allowed to spend half an hour there. But that is everything. That is our solving inequalities by graphing.